So hello everyone. So today we are going to discuss about Deep Research Archive. So this is a system that do deep research. So we will today going to see how to develop your own deep research agent. So let me first discuss about the core architecture of the system. So first, the system will take a prompt from the user, and based on the user prompt, it will call archive API and find all the relevant papers related to the prompt. After it has found all the relevant papers, so what if the domain the user asking has not enough relevant paper? So in that case, it will just print we there are no enough relevant paper. So if there are enough relevant paper in the archive related to the user prompt, only then the system will continue to proceed. So after the system has find all the relevant paper, it will just prepare references. So what it is going to do is that it will uh, extract all the metadata and abstract, title, and other stuffs, and then based on that, it will construct a prompt of reference. So this prompt will be given to the language model we are going to call through OpenRouter. So we will actually go through 20 to 70 or 20 to 100 papers. So for each of the paper, we will add all of their information like abstract title and other stuffs. And when all the information of each of the 20 or 70 paper has been included, then this will consider as a prompt. This will be considered as a prompt, and then this will be given to the model. So this model is going to be called through the OpenRouter API. So you can also use Olama to locally host the model, but our implementation basically integrate the OpenRouter API. So basically, it is a universal API providing platform. You can just put on your respected API key, and it will route the model that you are trying to use. So you can also define which model you want to use, and based on that model, you will just put the API key of the provider. The OpenRouter API will automatically figure out the model, and then it will use it for your activities. So first, we will pass this prompt to the model. The prompt we have constructed in these steps. And now the model will just generate a literature review based on those information. And it will also cite, because we have also generated some citation based on those count papers. So after the literature review has been written, then it will actually write the reference section. So reference section will be written in two formats. First, it will write reference section in IEEE format, and then it will write the reference section in BibTeX format. So now there are total 3 steps. One is preparing references for each of the sentences, and then the overall literature review, and then the third part is the reference section. So in this last part, our system will combine all the 3 things, combine references and literature review, and in the final step, it will output the result. So now we are going to see how to develop this agent step by step. So let me go to our repository. So you can see this is the main file, and there is also a interface file. So today we are not going to focus on the interface. We will only focus on the main research work. So first couple of these lines. These lines basically are the import. So we need to import some libraries. So basically to asynchronously call the API, sorry, asynchronously call the model. Okay, hold on, I have to do something. So basically, what async IO does is that it actually asynchronously call your program, like allowing multiple tasks so that it can run concurrently without blocking. It is basically used for the API calls, and the AOI HTTP basically does it is used to make API requests to open router and archive. And nesting IO basically this library does is that it actually allows nested use of async IO, and which can be useful for integrating multiple frameworks like Streamlit, because each time we refresh the interface, it will actually regenerate the whole process again. And XML tree is basically for parsing the documents that we will going to uh, extract from the archive API. So let me enter into the main part of the code. So these are the API endpoints. We need to initialize them, and we are using here Gemini 2 flashlight because it is free. So you just need to plug in the API key, and then you can use it without having any API tokens. So here you can see the next steps. It is calling open router API. So you need to just provide some header and payload. These are nothing special. You can find this code in the documentation of the open router. And then if your request is successful, then it will send the message and wait for the API to give a response. So it can give you successful or fail. So based on that, this function will print something. If it if the API has any kind of error, it will print error, or it will just tell the error during that API router call. And if there is no error, then it will automatically pass on the next step. So in the next step, we will can see that it is in this step, the search archive papers sync. So we in this step we will actually call all the we will call the archive API and collect all the relevant papers that user actually prompted. So basically, user didn't prompted any paper; they just prompted their ideas, and based on their idea, we will try to search, archive, and find relevant prompts. So in this step, what we do is that these parameters are already set. This is based on query. We will start from the zeroth index, and maximum result is actually the paper count. So if the user user can set the paper count in the interface. So if the user set a lower count of the paper, then the literature generated literature review will be shorter and it will take less time. But if the user give a lot of paper number, like 70 or 100, the generated literature review will be much more larger and it will more time to process. So, and basically archive doesn't require a API key. So you can just call it and it will just work. So in this phase, the first, if the response is successful, it will move on. And then in this part, what are we going to do? What we are going to do is that we're going to extract all the relevant information like title, abstract, URL, authors, and published element. And the next step, we are going to just chunk the relevant part, and we will then append all this chunk part in the paper entries. So first we will do it for paper number 1, then again we will do it for paper number 2. And if the user query requests more than 50 paper, then this loop will be continued for 50 times. And then if there is an error, there will be, this will print the error statement, and no errors, then just we will build the, we already told the, we have already discussed about this in this section. Then based on the user's query, we will just prepare the reference, and based on that reference, we will construct a prompt. And that prompt is basically what? That prompt is basically the summary of all those 70 papers that user requested for. So after this step has been done, then we will move on to the second step. So this step is preparing reference. So we will prepare reference in two format. One is IEEE format, and then the next step we will generate reference in the BibTeX format. And then this is the main part of the code. So in this part, the literature review will be generated. So first we will mention the references in every relevant, where once we will first collect the information from the paper, and then we will provide reference when something from our prompt. Prompt means the information we already stacked up in the previous step. So when something is called from that information stack, we will refer it according to the key of this particular information. So this is the part of providing reference in the literature review. And in the at the end of the overall literature review, we will again print all the references like the standard way, that in the way the academic papers are written. So first, this is the main important part. This is the secret sauce of the system. So if we refine this review prompt, the more refined the review prompt will, the more our generated literature will be better. So first, we have mentioned here that how use formal natural journal style, then begin with a compelling introduction and organize the findings, and then write the overall literature review in a narrative flow. So these are the way. So this is the prompt. This is the main secret sauce. So you can also you can try to improve this review prompt and can get better response. And in the last in this step, we have given this review prompt as a instruction prompt, system instruction prompt, and based on that, the literature review will be generated. And first, the information, and then this prompt. Combined with all of this, we will pass the prompt to the model to generate the literature review. So in this step, the literature review will be generated. After the literature review generated, we will generate the reference and BibTeX citation in this format. This is a section separator, so it is basically, it will print some marking equal mark to separate the three sections, and then finally we'll just start our research flow multiple times. So user will give a prompt and paper prompt. It is basically necessary for the interface, so we will no longer need to think about the interface now. We'll just, this is the most important part of our code, the literature review generation section. So now we'll see how the system actually work. So you will just put your open router API key here. So the system will be activated, and then you'll just give a prompt. So here you can see there's a example prompt given. So quantum machine learning for drug discovery. We'll just copy it. Okay, let me, what is the, you can also just time compute. So we don't need to specify things, just we can pass the keyword, and the archive API will automatically, the system will automatically find the relevant papers. So you can actually, minimally we have to give 10 papers, and you can also give 100 papers, but not more than that. So let me try with 25 papers and start our research. It will take a couple of seconds. The analyzing is already started. So the main step of analyzing is this part. So in this part, the model is trying to reason through the paper's knowledge, and then it is trying to formatting the literature review based on this prompt. So the core intelligence of this system is coming from this prompt. So we can actually refine this prompt and get better response. See, this is the literature review generated. It actually took 30 seconds. So which is actually way faster than the deep research available in the OpenAI platform. But the difference between OpenAI and this deep research agent is that this only does the search in the archive, and OpenAI system, or OpenAI deep research actually search over the entire internet. So, and then it also needs to embed all the web page, so it takes actually more time. But as we are directly using the archive API, so we are just doing what we are just taking all the information from the API, archive API, and then just putting all the information in the model. So it is, we are not doing anything like RAG. We are doing something called CAC. So we are using the entire prompt, and based on that, we are doing in context learning, and then the system is generating output based on our review prompt. So you can see this system has generated a detailed literature review of 25 papers, and you can also find 25 papers in the reference section and in the BibTeX section too. We can just download the literature review using this button, or just copy paste it. So this is the core part of our system. If you like this system, please give a Like it is also available in the Hugging Face space, and you can also just use this repository to generate it in your own local machine. So if you like this video, then please give a like and subscribe. Thank you. In the next video, we'll explore something new about agents.